Hi, welcome. We are doing notes 9-1 today, which is page 20 in your note guides. We're going to be talking about similar triangles, similar right triangles specifically. I'm going to use a lot of highlighters and colors, and I'm going to do a chart, which I don't think Mr. Christensen ever uses the chart specifically. I like the chart. I don't believe he uses it, so you can memorize the rules or the chart, whichever works best for you. If the altitude is drawn to the hypotenuse. So right here, we have a right triangle. There is an altitude being drawn to the hypotenuse. When I do that, it is going to create two more right triangles. Those two right triangles are going to be similar to the original and to each other. So now all three triangles are similar. Looking at it, it's hard to figure out which side corresponds just looking at it. So you have two options. The first option is that you can redraw it, and I can redraw it and say, well, here's the longer leg and the shorter leg. So this really over here is going to be A, C, B. If I draw them also, they are oriented the same, then I can look at them and visually see everything in the same order. If I go to the medium triangle, the longer leg here is AD, and the shorter leg is DC. If I go to the small triangle here, the longer leg here is CD, DB. Now it becomes trickier if it's a really close triangle, almost an isosceles triangle, and you can't really tell which side is the same or which side is longer or shorter. Then it becomes a little bit more tricky. But I do know that all these triangles are similar, so AC is similar to AD is similar to CD. You could set up proportions for all three sides. If I were going to do this, again, I could redraw all three of these triangles. I'm going to pause my video and redraw the triangles actually in order for us. You probably don't need to watch me draw all the triangles, and it's kind of tedious and time consuming. So you can pause and draw yours. Now, I want to label everything I know about the triangles. So I know that CB is 12.3. I know the bottom here is 7.8. I know that in that medium one, the only thing I know about the medium one is 12.3 right now. The hypotenuse, I don't know this leg because I know that whole value. I don't know the piece of it. I do know that this is a variable. DB is a variable, so I can go ahead and put an H here. Over here I have 7.8. And then I know that this is my H in this case. So here are some. Once I do this, it's easier for me to see what corresponds if I need to set up a proportion and solve for H. Identify the similar triangles in the diagram, so I just identified them. Now I want to find H. So I'm going to set up a proportion here. I need to decide what's going to go together. I could, because I know two pieces here, I could either use I believe I can choose which one I want to use. I need to solve for H. I can either use this and this to solve for H, or I can use this and this to solve for H. And the only reason I can do that is because I do know the hypotenuse here of 14.6. That's when I was looking at it and I was missing that piece. The hypotenuse is 14.6. So I did need that piece of information before I can set it up. So I can choose either the small or the medium. It's kind of up to me. I'm going to do the small because it's a smaller number. So on the larger one, I know the 14.6. And the hypotenuse of the smallest one is 7.8. So if I were making a chart around this to make sure that I was consistent, I would go ahead and say that I'm putting the hypotenuse on the top. This is my largest triangle, and this is my small triangle. I can decide then if I'm using the small triangle, I'm doing the height. So the height is H of the small triangle and 12.3 of the large triangle. I know we can all cross multiply and divide. I'll go ahead and pause while we do that. Some of our videos get so long. So cross multiplying, I get H times 14.6, 12.3 times 7.8, and then I'm going to divide by 14.6. So all of us are using calculators right now. We can get 6.571. Okay, going to the next piece, I'm going to start using a lot of highlighters. So if you have highlighters out, I'm using pink, green, yellow, orange, blue, and probably even a purple. But I'm not sure about the purple yet. So, starting out here, I have it pre-highlighted. Our first rule. Now, again, this is where we're going to come into rules. You are more than welcome to memorize the rules. I don't tend to memorize them. I do kind of now because I've been teaching this subject for probably 14, 15 years. But it's not something I really memorize. I memorize the chart that I can set up, and then it sets the proportion up for me. So it's up to you. My problem is that I don't know that you're going to remember it in a year and a half when you go to take an SAT or ACT, but setting up the chart is kind of a process, and that's, I think, is easier to memorize than the rules themselves. So again, up to you. Altitude is the geometric mean. So remember, the geometric mean goes across like this between the pieces of the hypotenuse that were created. So it is the geometric mean of the altitude. So I'm going to put A here and here. And then the pieces of the hypotenuse. The two pieces of the hypotenuse are D and E. And instead of a geometric mean, cross multiply and divide. That's your rule. The next one down here says a leg of the big triangle. So let's say that this is the leg I'm talking about. Doesn't matter which leg really, but let's say we're talking about B. A leg of the big triangle is the geometric mean. So if I were setting this up, the leg would be the geometric mean. It would go here and here. Between the piece of the hypotenuse closest, so one of the pieces of the hypotenuse, and the whole hypotenuse. The whole hypotenuse. So that would mean that B is the geometric mean. It would go here and here. Now that's one of the legs of the right triangle. The part of the hypotenuse closest to it, which is, it's an easy rule to remember, so part that's closest is going to be D. And then the whole hypotenuse, let's go ahead and name the whole hypotenuse here F, just for fun. Now, you could do this with the other hypotenuse, or with the other leg as well. Let's say the other leg is our C over here. So the leg is the geometric mean. So you would use that one as your geometric mean instead this time, making it C here and here. Now, what's the piece closest to C? Well, the piece closest to C is going to be our E over here, and then the whole hypotenuse. And the whole hypotenuse is our femoral F. So these are our rules. This one I do memorize. You split it, divide it into geometric mean, those two. This one, the geometric mean of the leg, side closest and the whole one, leg, side closest and the whole one. So we're going to try some of these out now. Go ahead and turn to the next page. Okay, so here are two really nice ones to start with. Go ahead and set them up if you would like. Now again, you can use your rule. I'm also going to go over the setup of the chart that I would create. Okay, so right here, and again, I like my highlighters. Geometric mean between the two pieces. This is the easiest one to memorize. So I'm going to put x here and here, 6 and 10. Cross multiply and divide, we get x squared. 6 times 10 is 60. I'm going to square root this. Well, 60 has a perfect square factor of 4 times 15. So I get 2 root 15. There we go. Now, this one tends to be a little bit harder for me to see right off the bat, so I do like to set up my chart. I'm going to create a chart up here just so you can follow along. Now the thing is that we have 3 triangles here. Generally, we have a small, a medium, and a large triangle. Sometimes it's hard to tell. You might do a right, a left, and a large. You always know which one the large one is, but sometimes you don't know really which one is bigger or smaller. So first, second, that doesn't really matter. There are 3 parts to the triangle. You have a hypotenuse. Now you have 2 legs. I'm going to give these legs names, and they are arbitrary. It is however you want to name it. I'm going to name one of them angle X to 90 degrees. I'm going to name the other one angle Y to 90 degrees. Now all this means, usually in class I have a whiteboard, I'm kind of going over on the whiteboard. But if I have a right triangle and I tell you this angle right here is 30, do you know what that other one is? 60. If I tell you this one is 10, you know this one over here is 70. They have to add up, no, 80. They have to add up to 90. If I tell you this one over here is 80, wait, we just did that, sorry, 70, this one over here would be 20. They have to add up to 90. So they will have to be the same every single time. Is there a glare? Sorry. So, because it will always be 90, whatever X is and whatever Y is, together they have to be 90. I'm going to make one of the angles X, one of the angles Y, and then 2 the 90-degree angle, or 2 the 90-degree angle. So if I come over here and I tell you, it doesn't matter. I can name this angle X or that angle X. I'm going to call this one X, I'm going to call this angle Y. Now, let's start with the small triangle here. You're starting with the small triangle, you might want to cover up the other one so you don't have to look at it. Now, this is the 90-degree angle in the small triangle. So from X to 90, there's a 5. From Y to 90, oh, because if that's X and that's Y, then this over here would be X, and this over here would be Y in the little triangles. That's what I needed to say. So you can fill all of those in. If you have a question, you're more than welcome to come to office hours and we can go over it one-on-one, or you can just memorize the rules. X to 90 is 5. Y to 90 doesn't have a letter, so I don't really know anything here for Y to 90. I do know the hypotenuse is Y. If I go to the medium triangle over here, my X to 90, again, I don't know my X to 90. My Y to 90 is 8, so I know this one, and I don't know the hypotenuse. So you're not going to know all the pieces usually. Now on the large triangle, it's a little bit trickier. If you need to redraw it, you can. So on the large triangle, all by itself, I have the X up here, the Y down here, and I know that on the large triangle, this is Y, so those Y's are not the same Y's. They're just arbitrary, like placeholders, like a place of reference. And then this I know is 13. The entire hypotenuse here is 13. So with the large triangle, I know my hypotenuse here is 13. I know my X to 90 is Y, and I don't know my Y to 90. I can see from this chart that I just created that I've got nothing else here, I've got nothing else here. There's my proportion. So I have Y, Y, 5, and 13, cross multiply. I end up with Y squared equals 65. So Y equals square root of 65. Now again, you can use the color coding from the other page if you remember. It's the leg was the pink one. So I could do the leg as the geometric mean. between the part of the hypotenuse closest to it and the entire hypotenuse. These right here are the same. So again, sometimes it's really easy to see the rule, you just set it up and that's completely fine. Sometimes I like to do the chart, again, personal choice. Coming down here, this one, in the diagram, xy is considered h minus 5.1. Okay, so that's important. Now, difference between the statue height and your friend's eye level. Solve for h. I am going to name this is the x that we're looking for, and this is the 5.1. Well, the x that we just mentioned, right, is that height minus the 5.1. I don't really use that one. I would use, I know that this breaks it down, 9.5 is the geometric mean between the two pieces. I'm going to call that piece up here x, and this piece down here 5.1. I'm actually not going to use this until the end because I think it's uglier to use in the equation. You could replace that for the x if you wanted to. I'm going to go ahead and solve this. I end up with 5.1x because, again, the altitude, and it breaks up the sides of the hypotenuse. So that's this rule over here. If I use my color coding, sometimes that helps us. So I'm going to go ahead and just color code those so you see. Gets 90.25. Divide, I end up with x equals 17.696. So that's x, and if I want to know the whole length of h, I'm going to add 5.1 to that. If I add 5.1, I end up with 22.796 feet. So that's what I'm looking for as my final answer. I don't think we have many that are like that. Mostly they're going to show up like this, and you have to set up your proportions. So, again, this is one that you can remember, have it memorized, do that, but I'm going to go ahead and set up my chart. Okay? I'm going to set up a chart just so we can kind of practice if you'd like. Is it small, medium, large, hypotenuse, x to 90, y to 90. Now, again, this is arbitrary. You can put your x's and y's wherever you want to put them. I'm going to call this angle x, which would make this angle y, which would make this angle y, and this angle x. And again, those are arbitrary. That's not the same x as the altitude right here. I'm going to go ahead and pause this, and you can fill in your chart.